Hello, everyone. Hopefully, everyone's doing okay today. I'll be live streaming here in a moment. I know I'm already live streaming, but I'm just getting everything kind of set up here behind me. Um, Making sure I'm not dropping any packets. Everything seems to be okay. Let me turn the music back up for you all just a little bit here, so you can hear that. I'm going to turn it down for me here momentarily. Let's see here. So I've got it blaring. There we go. And just popping out some tabs here. There we go. All right. As always, I'm on the Code Black Tech Slack community. But first and foremost, let me go ahead and say hello. Good morning, good evening, good afternoon, whenever you're watching this. If you're watching this live, it is Saturday, the 26th of June. We're about to be in July here in the next few days. So I figured that I'd go ahead and talk to everyone today about SQL joins. Um, One SQL join that I really do truly understand, and a couple of joins that are always very difficult for me to know not how they operate, but when to use them. So, and those are the outer joins. So before we get started, as always, like, share, comment, subscribe to this video. Um, Go join the Code Black website over there on, or like the web page over on Facebook. You can get access to the site community. Also, I have another channel where I do some cooking. That's Squealer's Delight on YouTube. I haven't posted anything in a couple of weeks, but I will be posting some other stuff here soon because I'm expecting to get a new smoker in. So yeah, let's go ahead and get started here. Um, I will go ahead and share my screen here. Make sure I do this the right way. There we go. Okay. And so there you see, obviously, my beautiful family. And today's lesson, like I said, we're going to be talking about SQL joins and what they are. So, a join in SQL is just a way to get data from one table and data from another table in one query and put them together to make a data set that you can look at. On a few of the videos that I've gone over, you've seen me use SQL joins, like inner joins. Um, let's go ahead and get to looking at, and I'm using a couple of web pages here that I do have down in the description of the video. The first one I'm going to go to is W3 Schools, and that's talking about just joins in general. So it says a join clause is used to combine rows from two or more tables based on a related column or columns between them. And they give an example here where they have an orders table that has an order ID, a customer ID, and an order date. Then they have a customers table that has a customer ID, a customer name, a contact name, and a country. Well, those are two different tables. But let's say we wanted to get all of that data together in one query. How would you do it? So you could query one table and gather the information, query the other table, gather the information on that, gather that information, put them together in an outside source, and make yourself a report or a result set. That's not what you want to do. So what you want to do is you want to create a table join. Now, the type of table join matters on the type of data that you expect to get back. So the first and the easiest one to understand are inner joins. Let's go over to our SQL Server Management Studio here, And I've got a larger database of information here that I copied down the Stack Overflow, a Stack Overflow database that has millions and millions of rows of data in it. But before we get too down the pike on that, what I want to do is I'm going to say new query on the Chinook database, because that's what I'm a bit more familiar with. And as always, when you're messing around with SQL, you're expected to understand what you're looking for, what's in the tables that you're looking for, where are the tables that hold the data that you need, where are those located at. If you don't know that, you're going to struggle when it comes to, querying the information. But for right now, what I'm going to do is I'm going to do the first and very basic join. Now, going into this, I expect you to already know some very basic SQL, how to do a basic select statement query, um, how to limit the number of rows that you get back. Because when we get to messing with that Stack Overflow database, you're going to see that there's a lot of rows of data in that database. So before we get too far down the road, let me go ahead and right click here and say, make sure I get all my messages here, because sometimes I don't get all my messages here. Okay, let's go ahead and go this. Okay, so what I'm going to do is I'm going to use the Chinook database, and up here in our SQL Server Management Studio, we see available databases, and in the drop down, we see that we have the Chinook database selected. So we know that that's where our data set is going to come from. So I'm going to expand the Chinook database and expand the tables. And in here we have our album artist tables and the tables that we've messed around with in the past in some previous videos. So let's go ahead and do a very simple select statement and find a number of rows in one of these tables. So we can do select. Let me make this a little bit bigger so you can see. Select count star, which is the wildcard saying give me everything from. I'm going to do invoice line, because I think that table has a number of rows in it. My keyboard is acting up here. Okay. And I'm going to hit F5, and I have 2,240 rows of data, of rows in that table. Okay, so I'm going to select everything from invoice line and see what comes back. Okay, so we've got an invoice line ID, an invoice ID, a track ID, unit price, and quantity. And we know that we've got multiple rows for invoice ID. So if you look in here, you see that we've got 2 invoice IDs with number 1, we've got 4 with number 2, and so on and so forth, right? So it makes sense if we look at the tables that we're messing around with, we have an invoice table over here. So let's do a select from invoice. And we can just highlight that one line and hit F5, and we'll see what we get back. Okay, so we have 412 rows in this table, and we have our invoice IDs over here on the left-hand side, and they're 1 for 1, which means that our invoice has a primary key of the invoice ID. So if we come in here, we can look, we can see our invoice ID is a primary key, and we have a foreign key of our invoice customer ID. And that's going to be our customer ID in this column here. So this column is going to join to the primary key from this table into this table, which is our invoice customer ID. And we see our columns in here. We have a line ID, we have an invoice ID, and actually our invoice ID, I believe, is going to be our it's going to be our key. So we can always just kind of double click on this key here to see what the key is. And we can see that this key is joined. Um, this key is the invoice ID, and this is our foreign key. Just script it. I'm used to using it this way here. Okay, so our foreign key here, it's a key constraint. Um, what it is we have a foreign key constraint on our invoice table, and that references our customer ID from our customer table. So I was right. We have a customer table up here, and in here we have our customer ID. So that ties the invoice back to the customer. So let me kind of back up here and say what I'm saying here. All right. So in our customer table, we have a customer ID that ties up to the demographic information of the customer. We have an ID, first name, last name, their address, their phone number, that kind of stuff, where they live, email, all that good stuff. Okay. The key for that table, or the unique identifier for that table, is the customer's ID. So each customer has a unique ID in that table that identifies them as the customer. Okay. Now, what we do in this invoice table is we can tie back to the customer's ID in the customer table and always tie that to a specific invoice. How do we do that? Well, we do that by joining our customer table to our invoice table first. Okay. And so to do that, let's use the simplest join that we possibly can, and that is an inner join. So instead of doing a select from invoice, we're going to come up here. We're going to say select star from customer. And instead of the select from invoice, we're going to do an inner join. And from, we're going to say inner join invoice. And we're going to give it an alias, INV. INV with no lock on inv.customer ID equals, and we're going to give cust a an alias here too, equals cust.customer ID. All right. Now, when I do this query, what an inner join is going to do, it's only going to look at the matches on the customer ID from my customer table to my invoice table. So if I have customers without an invoice in there, those won't come back in this join. So the most invoices that I should have back, well, if I look at that and if I group those by invoice, by customer ID, if there's one customer ID for one invoice, I'd get 412 rows back. If one customer has multiple invoices, so let's say if we had customer 4 ordered 5 things and they did it on different invoices, then he'll get matches back for all of those. But my join will come back and will match my customer ID and all of the invoices per customer ID. Okay, so let's go ahead and see how this join works. And again, this is called an inner join. You're taking data from one table and you're matching it to the other table. You only are displaying what matches. And let me go to the W3 schools here, because they should have, there we go. So what this is, let me zoom in here real quick. This is a Venn diagram that shows when you do an inner join is only going to get the matching rows from table 1 and table 2. Anything else that's in table 1 and anything else that's in table 2, it won't be displayed, it won't be seen. You're only getting the matching rows that match your criteria from table 1 and table 2, and that's your new data set. Okay, so if you had 3,000 rows in this table and you had 3,000 rows in this table and only 100 rows meet your criteria, you will only get 100 rows back in that area. Okay, so let's do this inner join and see what we get back. And I have 412 rows, so that means that as I look at this, the only thing that's happened is that we have um, one customer ID to one invoice in the table. So no one customer ordered more than one, has more than one invoice in the table. Okay. Now you're looking at this and you're saying we've got customer ID, we've got a bunch of these different first name, last name things in here and all that kind of stuff. We've got our rep ID, we have our customer ID, we've got all this stuff in here. What we basically just did is we took the data from both of those tables and we made two tables into one table, basically like a temporary table or data set, right? And you really don't always want to do that. There's different ways to do that. In an inner join, you're only going to select the columns that you want to come back in your query. So instead of selecting everything from both tables, let's say I only want to get back the customer's first name, their last name, their address, state, state, and zip, and maybe an invoice number. Okay, so let's do this. Let's say customer ID. We're going to say My keyboard is acting up here, y'all. What is going on? All right. So we've got customer ID. We've got our first name, first name. And the reason why I'm putting the alias in there, I don't have to in this instance because our invoice table only has an invoice ID and a customer ID. It doesn't have the name in there. So it does have a customer ID in there in both tables. So if I don't put the alias in there, because that's what we're joining on, I'll get a little squiggly line and I'll get what's called an ambiguous reference error because there's a customer ID column in both tables and SQL Server wants to know, well, which column are you talking about? And that's very important because you don't want to reference the wrong column, especially when you're joining on something. So what we'll do is we'll say customer ID to keep it simple. And we can also put an alias on this like we did with our table, and I can say cust ID like that. Then I can just put first name, last name, and instead of that, I'll just put their email. And let's say I want their invoice number. Let's say invoice ID in there like this. Okay. If I F5 that, now I have their customer ID. I have all of the invoices for that particular person. Okay. I can see that customer ID number 1, which is Luis Goncalves, I think. He has these invoices where he ordered something. Okay. I can even put the invoice date on there to make it clearer. Invoice, goodness, my keyboard is acting up, y'all. Invoice date, comma, F5, and see, we can see that the days that he ordered, let's order that. There we go. I actually want to do it by customer ID too, so. Oh my goodness, this keyboard is killing me, you all. Wonder if I need to change the batteries in my keyboard. Always be ready. Okay. Let's see if this does it. Oh, these are AAA batteries anyway. Well, I still should have some AAA batteries in here too, though. And I do. Bear with me, y'all. Technical difficulties here. Just throw these back in there, put those back in there. Flip these over. I bet you it's the battery in this thing is going crazy. Bam! That was it. Okay. There we go. Now we're in business. All right. So we're going to order by customer ID, by our customer ID, then by the invoice date. Like that. So there we go. And so we have the invoice date. We have the customer ID in the right order, like we had before. We've got the invoice in descending order. We've got the person that ordered them. Okay. So this is just a regular inner join right here, where we're joining on the key of those two tables. Now, it's a good rule of thumb to always try to join on the primary key of a table, because that's the point of a relational database system. They have a relationship. Each table has a relationship between one another in some way, shape, or form, or at least the ones that you're looking at. They have a relationship between one another. And so you want to use that relationship to get the most unique uh, data back that you can. All right, so that's an inner join. Now, what is an outer join? An outer join is slightly different. Okay, let's go back to our example here in W3 schools. All right, so an outer join or a left outer join is when you're going to return all of the records or the rows from the left table as well as the match records from both tables. And only that. You're not getting any other data from the right hand table. And that looks like this. This is called a left join. So why would you use this? And this is the thing that I struggle with quite often, because I'm so used to just matching on the things that I need and getting what I need back. Why would you use an outer join? Well, let's say that the report that you are going to create is still, let's say the report that you're going to create requires you to give every single customer in your table, right? So like right here, you don't want only the customers that have data that are in this invoice table, okay? So let's do a quick query. Select star from, actually let's do, instead of select star, let's do select customer ID from invoice. And that's say distinct. Let's see if we get 412 rows back. We actually get 59 rows back. Okay, so that means that there are right around 300 50, 60 people, maybe. My math is a little off. There's some people in the customer table that don't have invoices in here. Okay, and we can see that they are numeric, and there's 59 of them. So, and it's quite possible, but we don't know because we'd have to do a query on that. So instead of doing an inner join on this table, let's do an outer join on these two tables and see what we get back. So we're just going to copy this query, and this is our outer join right here. And instead of doing the inner join here, we're going to do a left outer join, and we're still going to join on the same primary keys there, and we're just going to run this to see what we get back this time. So we still have our 412 rows back. So that means that and we don't have any rows in here that are not in both tables. So let's go ahead and insert a row into our customer table. So let's do that. Let's say insert to customer. And we're going to put a customer ID. Is that a, let's make sure that's not a identity field. Is it identity? No. Okay. And we're going to say customer. You know what? SQL Server Management Studio has a really spiffy little thing that you can do. You just right click on the customer name, go to script table as, and say insert to, and it draws it out for you. Oh, I ain't got to guess. All right, so let me make sure I don't have any Slack chat stuff here. No, I don't. Okay, so we're going to try to grab the right customer ID. I think 59 might be the... What is wrong with my PC here? Okay. Select max from customer. Okay, 59 is the maximum one. All right, so we're going to insert 60. It's going to be 60. Ooh, that's driving me crazy, y'all. 60. We're going to say test name 1. It's going to be test last name. Company is going to be null. Address is going to be 123 anywhere street. It's going to be anywhere USA. US. Wait a minute. We'll put it in actual state. Country is United States. Postal code is going to be 68111. We're going to make him a null for the phone number. We're going to make the fax null. We're going to make the email. It's going to be anywhere at usa.com. And support rep ID is going to be null. And over here on the left, we can see the things that we can have that are nullable. So first name, last name can't be nulled. Customer ID cannot be null. And email cannot be null. Everything else can be null. So we've got that. So we can hit F5 or we can hit execute. We can just close this here because we don't need this. Now let's do our inner join. Again, we should still get the 412, but if we do our outer join here, we get 413 rows back. Why do we get 413? Because we have the one row that meets the criteria for our outer join, and it should be this last one here. And you'll notice that in here, I don't have an invoice or a customer ID. I have a customer ID, but I don't have an invoice ID or an invoice date. The reason why these are null is because they do not exist in our joined table. So invoice ID and invoice date, which would be in this invoice table, don't exist for this customer. And so because they don't, I get the data back, but I don't have any invoices, right? So since I don't have any invoices, I can still print this out and say, hey, this customer has no invoices, but they're a customer in our table. So let's say I was the person, I do stuff with leads, right? I'm in sales or marketing, and I do stuff with leads. I have a customer that signed up for the service, but they've not ordered anything from us. I can put this out there and say, hey, I noticed that you signed up for our service, but you don't have any orders. Can I help you with something, or is there something wrong, or do we not offer the product that you're looking for? That would be a prime example of why you would do an outer join on the left table. You want all the data back, but you want all the data back, but you don't want to lose any data either, because you're going to take an inventory of the entire table, because it's your customer table, right? You're generating leads. Okay, now that's a left outer join. I should mark this the right way. Left outer join. Now what about a right outer join? What do they do? Well, let's go back to our example here. Right outer join just does the opposite of what a left outer join does. Now, what that means though is that your data will differ. It may differ depending on what's in the other table, because we know there are 412 rows in this customer table, right? But we've got a different number of rows in our invoice table. So let's do a right outer join and see what we get back here. And we're still joining on the two tables. So instead of returning the rows that we need from, or the data that we need from this left table, which is our customer table, we're now going to join, we're going to get back the rows that match in both tables. That's our inner join part, and then we're going to tack on the stuff that's in the right table too. So let's see what we get back when we're on this one. So we still get our 412 rows back because we've got matches, and we're missing our one table, our one row, because if you remember, that row is not in our invoice table. That's why we were able to get 413 rows back from this one. Let's run these two side by side. So this one, we got our 413 rows back because we have a row in our customer table that we inserted. Remember, we have that row that we're returning as part of our outer join. In the second join, our right outer join, we don't have a row for that particular customer in that table because it's an invoice table and it doesn't match, and we don't have a row that matches that particular one, and we only have so many rows in that table. So because of that, we have the 412 rows that came back in that second query. Okay, now, so that's a left and a right outer join. Full outer join will get everything back, all the matches and both sets of data from both tables. So let's do a full outer join. Just copy this, paste this in here, and this is a full outer join. Take that off of there because I don't know what that is. And instead of saying right, we're going to say full outer join. Is it full outer join? Or is it full join? Is it full join? I can't remember. I haven't done too many fulls. All right. So in this instance, with this full join, or is it full outer? It's the same thing. So in the full outer join, we get all of the data from both tables, plus we have our extra row from our leftmost table. Okay. So if I had another row in this invoice table, it would show up here too. So I'd have 414 rows. Okay. Let's see. Am I getting a text here? Am I getting something back? No. Okay. So that's the left, the inner, the left, the right, and the full outer join. Now, let's go ahead and do this on some rows in a database where we got a lot of stuff coming back. So I'm going to close this query here. I'm going to close this query here as well. So here we have some examples from, let me zoom this back out here. And these are the common joins that you're going to use, okay? I've got another example from another database here. So again, we got inner, outer, cross joins. We've got left outer joins, right outer joins, full outer joins. There's some other joins that you can do. I've never done a self join. The majority of the joins that I've used, you're going to have inner and outer joins, both left and right. You're going to have cross applies. You're going to have outer applies. Outer and cross applies are very similar to inner and outer joins. They can be more efficient to use at times, and we'll go into that in another video here. But let's go into this other table and see what we have here. So this is an example of an inner join and outer joins on the same sets of tables here. And I'll do a cross join, a full outer, and I'll do a cross join example. And you'll see why it's so important to know exactly what you're doing here. I don't think that you want to do that. Let's see what happens there. And you'll see down here, I'm going to get a ton of data back. It's still going. This is why doing a cross joins, you you got to be very careful when you do cross joins, because you're pulling back data from both tables. Okay. And it's still going. I'll show you what a cross join is. So it's a Cartesian or a cross join, and you're basically going to take a record in this table, you're going to join it in a record with this table. There's no on, and then what you're going to do is you're just going to go ahead and run it, and you're going to get a whole bunch of stuff back. It's still going, right? So if I stop this, you'll see millions of records, millions of rows, 7,174,726 rows. So I'm not going to continue to run that. Okay, I'm not going to continue to run that one, but I just want to kind of give you an idea of how a cross join would work. So, and actually, you'd probably just do something like this, because you're joining two tables together basically, and so that's going to grab everything in both tables. Okay. So we're not going to run that one because that's a killer right there. All right. Now, inner join, remember, Venn diagram, you're just getting the slice in the middle. That's this one right here. If I run this, I get 224,611 rows back in about a second and a half, probably. Yeah, almost 2 seconds right here. Okay. If I run the outer join, I get almost 300,000 rows back, but it takes a little longer. It took 2.5, almost 3 seconds. Obviously, because I'm pulling more rows back, but also because I'm doing the join as well. And so if we look in here, we see we've got badge names in here. We've got some that have data, that have some that don't have data. So what you can do, if you want to use an outer join, if you still need all the data, but you can do a filter on it, where all you do is you say where badge b dot name is not null. And when you do this, watch what happens. It speeds up your query, and you'll notice that I now have 224,611 rows back, which gives me the same number of rows back as my inner join. Okay, so you do have to know what you're getting back, right? Even though this data is going to be slightly different. If I run this, so you see, if you look down to rows 4, 5, and 6 here, let me do this. This is rows 4, 5, and 6 of that particular run there. If I run rows 4, 5, and 6 on this one, oh, I did get back the same. I did get back the same stuff. Anyway, so you can do a filter on an outer join, and it's best to kind of put some kind of a filter on any join that you have. Don't just do the join on, don't just do your query on an inner join. Put a filter on it and filter your result set. It's just better practice, and it makes your queries go, your data set, smaller. So let's say I say it like this. I'd say, run this one, and I come through here. None of these are null. So let's say I say where name is like supporter. So let's see how fast this comes back. So I get 21,532 rows back in 1.886 seconds. And if I just run this, 1.930 seconds. Let me run it one more time here. Let me pin that there. I'll run this a second time. 1.9, 1.8, 1.8. Now, if I put the filter on there, 1.2, 1.2, 1.3. So you're thinking in what, 600 milliseconds? It's not a lot of time, but when you're filtering through hundreds of thousands of rows of data per second, it adds up. It adds up, especially if you're doing an insert, right? So that's an example of doing some filtering on an inner and an outer join, okay? So I'm going to take that off of there. So here's our right outer join, and we did a full outer join. Now, if the full outer join, no filter, Watch how long this one takes to come back. 2 seconds, 3, 4, 6, 8, and we've got 9 seconds, almost 10, but we've got back over 1 million rows of data. And when you're talking about in an environment where your program may not have direct access, and I'm running this on the same box, right, as my database, your program may not have access to that database. It's got to go over a network connection. It's going to take longer. Okay, so you want to make very efficient queries if you can. So we've talked a little bit about inner, left join, right join, and full outer joins, right? Left outer join, right outer join, full outer joins. When you would use it, why you use it, and understanding exactly, what you're looking for. Now, let's do a little bit of um, let's do some query stuff here. Okay, let's make a temp table. Okay, so to make a temporary table, I'm going to take this inner join here. Okay, I'm going to say new query, paste it in there. Then what I'm going to do, I'm going to say select star into # or 3, number 3, temp table. And what that does is it's going to create a temporary in-memory table for me that I can go out and query with a data set. So I hit F5 here, and it says must specify table, blah, blah, blah. Okay. Select into temp table, an object is missing, or... So what I need to do is I need to make a subquery from, like this, sub q, select, let's see if that works. There we go. Now, if I go over and I can say select from temp table, I should have 224,000 rows in there, and I do. Here's my 224,000 rows. Okay. Now, let's say I want to keep inserting data into this table, but I don't know what's getting loaded into the table. One of the cool things that I've learned in the last 2 years is a way to do what's called, I learned this from work actually, and we call it a safe insert. And what a safe insert is when you're going to do an outer join on the same table that you're joining into, but you're checking to see if there are rows in that table already that match what you're selecting in what you're inserting into. Let me back up and kind of explain what I just said. Okay, you've got a new table. I have a new table, hashtag temp table or # temp table. It's a temporary table. If I want to keep running this query, if I run this query again, what's going to happen is I'm going to get an error that says that rows already exist in that table with that. See? And it says there's already an object named temp table in a database. Actually, let me drop this table. Drop table, temp table. Because what I'm going to do is I'm going to create a row number for each. So like it's going to be like my primary key. Okay. Or what I can do is I can say, what's in my users table? What's in my users table? So let me come over here and see what's in my users table. Should have a key in there. I have an ID key in there. So I'm going to say u.id. right. Let me revive that. Select star from temp table. And if I try to search on this temp table, it says it does not exist because it's just a temporary table. Let's see what happens if I try to insert into UID. Instead of it being this, let's say UID ID display name. And we're going to say that one's okay. All right. Insert ID, comma, display name. And actually, I'm doing this wrong here. Insert into temp table. And it's going to be ID. And it's going to be display name. And it's going to be badge name. From and let's see, and select to there. Let's drop. There's a table called temp top table. Temp table. All right. Get rid of this and insert that. Now, if I try to do an insert into, ID, display name, badge name, from, do another subquery, do that there. Insert into, I don't need that, I need this right here. Let's see what happens here. It inserted another 2,000 rows, 200,000 rows. So now what's going to happen is it's going to, if I do a select from that temp table, I should have over 400,000 rows in that table now. And you'll see, and I don't want to do that. I don't want to have duplicate rows in a table, right? So the way you can do that, if I drop this table, drop table, drop table, temp table. Okay, so now what I can do on this select, on this second insert here, I can say select ID, well, I gotta put the from here, select ID, display name, oh. it's harder than I should be here. Like this. I can do an inner join on this, and then I can say outer left outer join temp table on ID equals year ID do it this way. Get rid of the aliases there. That'll join temp table on ID, and it doesn't like that. Ah, that's why. Insert into blah. Select this from you. Let's put u dot id on temp table t dot id, and this t dot display name equals u dot display name, and t dot badge name equals b dot name, where TID is null. And temp table doesn't like that. Oh, did I drop that table? There we go. Let's try to do another insert in there. And you see we got no rows back, because what happens is this check right here it joins on itself. It joins the table to itself, right? And it says, hey, give me all of the matches on this temp table where I don't have a match. And so that way, what happens is I can't, if I use this logic, and this is what we call a safe insert at my job, safe insert logic. And so what that does is it prevents you from trying to insert rows into a table that already exists in that table. So if I come back down here and I say select star from temp table, I should only have the 200,000 rows in there. Yeah, see? So what I can do is I could run this. Now, if I do this, what this is going to do is it's going to do the insert for me. So I should probably put a safe insert on this one too, huh? So let's do an inner join, let the outer join like we did here. And I'll have to play around with the from T U S D D there, and T on this would be D dot ID, D dot nope. This would be well, I wouldn't want to do this more than once. This creates my initial table, so you just would want to run this one time. As it creates our table anew. So this doesn't have to be run again. So this one, if I run this, it will continue to have the same number of rows in the table no matter how many times I run this. Now you're wondering why I've got this is because I need to come over here and refresh my cache here. There we go. And that should disappear in a minute here. Bye-bye. The little squigglies will go away because this temp table, it does exist. So that's why you're seeing that there. So it's going through the database and it's refreshing all the stuff in there. So, but yeah, so I can go through and I can keep hitting F5 here, and it'll always come back with the same number of rows back because of this safe insert logic. But if I comment this out here, you'll see that my temp table is going to double in size here every single time. See, there it goes. And I'm going to add another 230,000 rows. See, it keeps going up. And all I'm doing is I'm just adding duplicate data. So a safe insert, what it does is it keeps you from messing up your table, right? That's what that does for you. Because I have 898,000 rows in there. So I put that safe insert back in there, and I should still have that same 898,000 rows in there. Yep. Because this safe insert prevents me from inserting rows erroneously. Now, if you're actually inserting stuff into a live table or a table with a primary key, you definitely want to have that in there. Because if you don't, what's going to happen is you're going to get an error. So let's build a table from our temp table. And then what I can do is I should be able to come down here and let me drop our temp table. Drop temp table, temp table. All right. So now instead of this being called temp table, let's actually build a table. We're going to call it create table, and it's not going to be called temp table. It's just going to be called display badge info. And we're going to have the appropriate fields in here or columns in here. So our ID is a primary key. It's an integer. We're going to call this ID, and we're going to make it a primary key. Int not null primary key. And we're going to have our display name, which is an invarchar. It's user, so we have name. Right there, it's 40 bytes. And it's going to be invarchar for 40 bytes. And it's not null. I believe that's not, says not null. Yep. And we have a badge name. That's another invarchar. And that's in the B for badges. Let's go for B for badges. We don't need no stinking badges. Alright, badge. Name is another invarchar for 40, so let's just copy that one there. And that's going to be not null as well. Okay, so let's do our insert into our new table. There we go. going to do another left outer join on this table. And make sure I'm not blowing anything up down there. I'm just going to run this one time. There we go. And then I'm going to do our insert into our new table. Do a refresh there, so that will go away eventually. And I should be able to do a select from display badge info. There should be 224,000 rows in there. Now, here's why I wanted to show you. You want to use this safe insert whenever you're inserting into a table that has primary key. If you try to insert into a table with a primary key, which user ID is our primary key, and I run this, I'm going to get an error because I'm trying to insert data into a table where the primary key has already been filled out. And then over here, it should show you which one that was giving you the wrong row there. So that's what this safe insert is for. Left, left. Because it prevents you from trying to insert duplicate rows into your table. And you see it says 0 rows affected there because the safe insert logic takes over and it keeps me from attempting to insert duplicate rows into my table. Works every single time. Oh, helps if I don't. There we go. Works every single time, right? So that's a good instance to use an outer join on a table because you can use that to prevent errors in your insert statements, right? Let's see here. What else can I show you? So we talked a little bit again. We talked about inner joins, left joins, right joins, and full outer joins. We talked about safe inserting or preventing duplicate rows from being inserted there. We talked about that. That's a really good practice. I didn't know how to do that until I got to the place I'm working at now. So make that a good practice. Make that a good practice for yourself. Right. So as always, this is going to be a shorter video than others. If you like this video, like, comment, share, subscribe. Go over to the Facebook page, Code Black. Like that page. Join up. Like, comment, share, subscribe on my other channel if you like cooking stuff. And yeah, that's it. So as always, hope this finds you well. Hope you learned something. I continue to learn, and when I learn something, I try to share it with you all as it helps me become better at what I do. So as always, peace, love, and blessings.